What's going on, guys? So for this tutorial, we'll be following up on some of the work we did previously. I think some of the core structure that we worked on was the feed-forward method, which is we use call for. We also implemented a self.build method that we're going to use to init our weights and biases. So just to make things clear, I have these as multi-line comments here just to show exactly that this is the feed forward. These are the arguments we're passing in. This is what we're returning. So for this section, we have to go more into actually initializing these biases and implementing exactly what self.build will do for us. So one of the things we need to do is we need to initialize the weights and biases for each layer. So just as a skeleton, it's really good just to see exactly what we're doing here. We're going to the weights of the first layer, so we'll call this layer 1. Initialize weights for the layer 2. Initialize weights for the layer 3. Biases for layer 2. And then finally, we need the final one for call it initialize weight for layer 3 and initialize weight for bias for layer 3. So what these are doing is just this will be our final neuron. So again, I'll do the skeleton for it. We sort of know that the final layer will have 1 neuron. This layer will have 10 neurons. And this layer will have 10 neurons. Okay. Good. And this is 10 and 10 because these are our 10 and 10 from our architecture. So one of the things that we need for this is for our first set of weights, as you can imagine, we want to initialize the weights for our 10 neurons. But what we also need is the size of the weights have to correspond to the number of inputs, or so the number of features in our X, right? So at this point, build just accepts self. And at no point here do we pass in the number of features, okay? So the features themselves are here, but not the number of features. So what we could do is, we don't really need to make it a class method, or sorry, class variable. What we could do is we can actually pass in self.build, and we can pass in the shape of the number of features, right? So what this is in fact doing is, okay, the shape of X is 2 by 4, and we want the number of features passed in to shape as x.shape here. So here we have the argument. So the argument is going to be shape of, or we could just say number of features of x, right? So just so that's not hard coded, and we know that's going to be 2. So that'll be argument there. And here we'll call it input length. Okay, so that works out well for us. So we have input length, which is 2. So we need to initialize our weights and biases. So what we're going to do here is we're going to use everything for default. What we're going to do is we have to set up the initializers for weights and biases. So this just shows, okay, our weights, how do we want to randomly distribute it, right? So we can set a variable called w initial, which is just our our weight initializer, and we can sort of set that as TensorFlow's normal initializer. So normal, random, not normal. So for those that don't exactly know what this is doing, this is pretty much just initializing W with, I believe the default is mean 0, variance 1, I believe. Okay, so the numbers are varied between -1 and 1. So this will be our initializer for weights and for our bias initializer. So what we're going to do is we're going to call that inishbias. And for biases, typically what you want to do is they're not that important starting off. So these can actually be 1s, or we can do 0s. Typically you do 0s. So we're just going to do that starting off, okay? So weights, what exactly will our weights look like? So first off, we're going to call them, we can call them layer 1 weight. I don't know if that's a good name. Yeah, so we'll just call that layer 1 weights. So what do we want to do? We want these to be trainable variables within TensorFlow, right? So we're going to call TF variables, and then we're going to pass in our winit, again, which is our initializer. So we're saying give me a trainable TensorFlow variable, initialize it with initialize them as random normal, and pass in the input shape. Okay, so and then our input shape. Okay, so this is important. This is what we need to really think about. What is the input shape for initial weight? And the answer is that the initial weight should be the features of our X and the architecture of our first layer, right? So what we're going to do is, I just want to double check the order of that. I just don't want to mess up. And so this will be our first layer of our architecture. So I'll just call that layer 1 arc. And then the next one is going to be X shape, right? So what is the first layer of our architecture? Well, up here, we passed in architecture and called it self.arc. And remember, that's a list of 2. So we can call it self.arc and just pass in the first one, right? So which is 10. And the X shape is actually going to be our input length. So that's already set for us. We already passed it in as input length, right? So we can make things a little clearer here. I think that makes it a little clearer, okay? So we have our layer 1, we'll call it layer 1W. Secondly, we're going to call it layer 1 bias, tf.variables. We're going to do the exact same thing. Here, we'll pass in our bias initializer and input shape. What do we want that to look like? And the answer is we want it to have self.architecture 0 and 1, okay? Because biases are just acting on the neurons going into the first layer. They're not a matrix. So self.architecture 0 and 1. Let's make sure it looks good. All right, and then we're going to do the exact same thing for weights in 2. So to make things easier, let's just copy and paste these. That didn't work out too well. Okay, so we'll call this layer 2 weight, layer 2 biases. Okay, and then we got to sort of think about this. So if our input here of X was input length and our output here was self.architecture, then the second layer, we want our input to be self.architecture 1. Oh, sorry, self.architecture 0, and going into self.architecture 1. So what this is going to do is it's going to create the second layer of biases. Just make sure. For the sake of things, we're just going to remove that. So what we're going to do is we're going to create a 10 by 10 matrix of weights, right? So we've got 10 neurons coming in, 10 neurons coming out, 10 by 10, right? So that sort of works with what we want it for. And again, this is just doing the exact same thing in. So that's an input. So the input of here is the first layer. Output is the second layer. Okay, and we have to make sure we call these something different. Weights 2, weights bias, W init. Looks good. Change that to 1. Okay, and then we're going to do the exact same thing for our third layer. We'll just make sure the comments are okay. So this will be layer 1. Well, that didn't work well. Okay, so we call it L1, L0, L1, and L2. Here, our input is the first 10 neurons coming into coming in from layer 1, and the output is going to be 1, right? Because we only have one neuron acting on the sigmoid, being either 0 or 1. And the bias is going to be this here. It's only going to be one bias, right? Because the bias just only acts on the layer going forward, right? So that's only 1. So we're going to call that 3, 3, 0, 1, 2. Okay, so that looks pretty good. Now the thing is, because this is a build, we're not returning anything, right? We're not returning anything, but at the same time, we want call to act on those weights and biases. So what we're going to do is we actually have to call self on all these so that they become class variables. And not only that, we can also access them outside of the class itself, okay? Okay, so once these are all built, right, look good, look good, look good, then we can go back to our call method. So I'm going to zoom out for a second just so you can see what we've done. It returns nothing. Self.build returns nothing. It's built, so we can go into our feed forward, okay? So with our layer 1, we'll call this layer 1 feed forward. Okay, we have to carry out our matrix multiplication, okay? So we know we're going to have some sort of z value, which is just the matrix multiplication. And the matrix multiplication is going to be our weights in layer 1. So we can call that self.layer. Is that what I called it? Self.layer 1. Layer 1 underscore weight. And our x, right? So our x is just a 2 by 4. Okay, so that works out well. And self dot layer 1 biases, okay? Looks good. And the next thing we want to do is our activation. So our activation, we don't want to use Z, but typically we can just use A for activation. And then we can just take the sigmoid. We're just going to keep things simple. And we're going to pass in Z1 as our activation, okay? So what we're going to do is we're actually just going to copy this. Once, twice, okay, so layer 2, layer 3, 1, 2, 3, okay, so we can just change things because we did name everything properly. We want to make sure that's all layer 1. So self.layer 1 bias, 1 underscore bias, layer underscore 2 bias, layer underscore 3 bias. We want to name these separately. Z2, Z3, A2, A3, Z1, Z2, Z3. Okay, so that we have our 1, 2, 3 layer. So everything's being multiplied by the sigmoid activation, and we have matrix multiplication, not matrix multiplication. And that should work well. So ideally, if we have a properly working feed forward propagation, we should return the last activation and see what that looks like, okay? So we're going to save that. And again, we have these 2 lines, which are just going to update that for us. So we're just going to make sure our x's and y's are executed. Our shape is 2 by 4. Let's just look at this. Learning rate is none. Architecture 10 by 2. Number epochs 10. Okay, so that works well. So when we initialize our model, what we're doing is we are passing in our architecture and making sure built is set to false. And then when we pass the feed forward for the very first time, what we're going to do is we're going to go down here, check if it's built. It's not going to be built. Build it, set it to true, and then carry out the feed forward. Okay, so since we just want to see the first layer, we're going to set the number epochs to 1 so that we only run it once. And then for the time being, we're going to make sure this, just going to make sure that never runs, okay? So that when I pass this in, model is not defined. Class model.architecture. Name model is not from, okay? So what we want to do is from utils. Actually want to import it. Save that again. Okay, so let's just guess and check exactly what we're looking at. So we did import the model. That error went away. But at some point, it's having an issue with tf.randomNormal. So it says tf is not defined. So that's because within our class, we need to import Tensorflow. Okay. Okay, so we're going to do that. Run that again. Module Tensorflow has no attributes of variables. Okay, so what did I do wrong? tf.variables. It's not called variables. It's called variable. Again, if you're not making these mistakes, you're not doing it properly, okay? Simple things like that happen. Random normal got next but the keyword input shape, okay? So for Airbro, it's not input shape, it's shape. Okay. Make sure that's all good. Save that again, run it again. Matrix size incompatible, 10 by 10, 2 by 4. Okay. So let's see exactly what we did here. So we made sure we passed in number features 2, random normal zeros, input length, architecture. So what is the issue here? 0011. So it's having an issue at which line? Let's just see. At Z2 in particular. Okay. At line 61. So we go back to 61. We see that Z2 is matrix multiply of the second layer weight times X layer 2. So you can sort of see exactly what went wrong here when I was just copy and pasting. So this is our output from the first layer. Therefore, it is the input for the second layer, right? And this is the output of the second layer. Input for that, okay. Go again, integer, okay, so that's, maybe it's just better just to remove that entirely. Run that. Let's just make sure everything looks like we want it to. And what we have is, okay, so we said that our output, what we wanted as our output for our feed forward was a 1x4 matrix corresponding to one guess as one neuron for each layer. So based on these random weights and biases, it's actually guessed at 0.6, 0.6, 0.68, 0.68 for all 4 of the neurons. And we can go back up and say, okay, given these feature 1 and feature 2, what were the outputs? And you can sort of see that it actually was right 50% of the time, and it's random, so that's what you expect. So it actually guessed this one right, and guessed these 2 wrong. Again, just based on the random nature of the weights and biases. So what we want to do is we want to train these, train the weights and biases so that we get better results coming out of here. And we can do this with our loss function with the next presentation, and we can show our accuracy and loss as we move forward. So with that, we'll see you guys in the next presentation, and we'll go over our loss function and our gradients. Thanks for watching.